Thank you, guys. Thank you all for coming today. And want to talk about our latest XR SDK VCR. Before we jump into that, let me jump to the next slide. Often when you hear about NVIDIA GPUs come to mind, understandably. One of the points I wanted to share with you is we are a full stack company. We have SDKs and extensions to enhance XR experiences, as well as tools and applications. And today, I'd like to run through one of our latest XR SDKs, VCR. My name is Peter Peng. I am one of the product managers on the XR team at NVIDIA in the business unit professional visualization. So one of the things I do is keep in touch and get a lot of feedback from developers and end users. From all of our team's research, we really understand VR developer challenges. And one of them, with the VCR SDK, many workflows are addressed. What we've learned is that the current VR experiences leave users and developers with a lot of challenges, a lot of unsolved problems. Users can't recreate what they see in VR or reproduce it in the exact same order to give that information to someone who needs to review it or assess it. And then when someone listens to a developer, listens to feedback and tries to recreate the exact head motion and button controls or inputs, it's nearly impossible, if not impossible, to recreate that. Developers really don't have a convenient way to test that VR content because they have to create the code, compile it, get into the headset, manually navigate to a scene in question, and try to recreate or confirm the problem is fixed. Then they get back out of VR and then go back in the application, rinse and repeat. So this in and out of VR we've learned can be very, at a minimum, time-consuming and tedious, especially when you have multiple VR headsets to validate an issue on. And then we've identified additional problems. Because testing requires a person in the headset, this creates something we understand as user fatigue. Because of that fatigue, testing sometimes gets compromised. The quality of testing is compromised. It's not as thorough. If anyone who has had to do any type of VR hosting or training, that user fatigue becomes another problem. Being able to consistently repeat instructions over and over again. And finally, when creating VR presentations, when you have multiple points of view in VR and you want to create that video or session, it can be time consuming again because of the amount of hardware required, the setup, and again, orchestrating multiple VR users. So I wanted to share with you what VCR is. We understand the developer challenges, and with VCR SDK, a number of the topics I mentioned are addressed. VCR records and plays back HMD controller motion and inputs. And with the VCR SDK, software developers can create tools to analyze and edit session data. Some of the benefits, with VCR, the capture sessions you have a more efficient way now to review content, reducing cycles in the headset, because you can actually rewatch captured sessions in your desktop window. With the recorded sessions now, you can remove unwanted controller inputs, smooth out headset and controller motion, and adjust retiming. And retiming specifically is you may slow down portions of your recorded session to focus in on particular details in the scene or speed up recordings based upon teleporting from scene to scene. Developers can actually rewrite and can write analytical tools using the captured motion at input. And now you have a clean, consistent way to look at user inputs and focus on how long they're gazing at particular details. Being able to capture a VR actor's performance introduces some really interesting ways to repurpose capture sessions and how to work more efficiently. With VCR benefits, I want to go into a few use cases. So it's interesting how VCR came to be. At NVIDIA, VCR was created so we could have more thorough performance testing. By recording a VR session, we could actually test and retest a VR application on a range of our GPUs. And as a result, we had the confidence that each test was identical. We also had the flexibility to jump into a specific VR scene by editing the VCR recording. And removing the in and out of the VR cycle reduced and nearly eliminates the user fatigue. And as a result, these benefits were then applied to our quality control and scene debugging. With a recorded VR session, and I'm talking about now pane 3 on your right, you can now actually have a VR host and instruct users through a training or entertainment experience. The pace, the menus displayed, and content would be consistent with each VR walkthrough by replaying the recorded VCR session. Finally, if you are using a VR application that supports collaboration, you can play back a VR session with multiple avatars to simulate collaboration, and I'll expand on this in a bit. So I wanted to share with you an example video that shows you VCR at its most basic, which is capturing video. Or excuse me, capturing the HMD motion and controller motion and the controller inputs as well. Ingo Esser is one of our developers who created this, and he'll be narrating in the brief video.
Here the app is already running. I am starting the capture tool. It logs all my interaction with the application while I'm drawing this complex geometry. Then I'm stopping the application. I am disabling the HMD. In this case, by actually turning off the link box of the Vive. I am installing the replay driver. Then it starts up with some small idle animation. And I'm starting the replay. It replicates my inputs and replicates my motion drawing the complex geometry again. And then I immediately start replaying the same recording while the scene is in this state to show that the geometry is ending up at the same place again.
So the next slide I'd like to show you is VCR segmentation. What VCR segmentation allows you to do is once you have a VCR capture, while you are capturing, basically you press record, it starts capturing. During your record, you can create segments by tapping the spacebar or mapping that spacebar to a controller, unused controller button. Once the segments are created, they can be replayed in any order. A really interesting use case here is for segmentation is to play back a limited part of the VCR capture and run repeated tests without having to be in the headset or end and restart the application.
In this recording session, I am generating different segments for teleportation, for switching on the painting tool, and for drawing letters. All of these different segments are separated by me pressing the left side trigger, which I'm normally not using in this session. And every letter contains me drawing the letter and teleporting to the left a little so that I can string these letters together in a different order later on. I have now switched over to the replay driver. In the meantime, I have generated more segments outside of this recording, like turning around or teleporting to a different part of the scene, enabling or disabling the paint tool. And we've seen how we've recorded the different letters or the segments for the different letters. I am now using this library of segments for those different actions, and I'm replaying them in the order that I need for my use case. Since it's taking a little bit of time repeating some of these segments, I will speed up some of this replay for now.
So after we started work on the VCR SDK, we started to share it with a few of our partners. One of them was Zero Light, and I wanted to share with you some of their comments and use cases as well. Zero Light is an international content creation studio. They develop visualization and VR experiences for the automotive space, automotive OEMs, to show off vehicle design and features for marketing and sales applications. This is a brief timeline and a number of projects they've worked on to give you an idea of some of the scope of their work. I wanted to go over some, like I mentioned, use cases. One of the things that Zero Light used taking advantage of VCR was really to optimize their VR development in two areas. One area was for quality control and bug reproduction. Their QA team used VCR to capture sessions, and using the segmentation you just saw, were able to create highlight tapes that were attached to bug reports. The developers could then replay their recorded VCR segments and understand exactly what the tester was seeing. Zero Light's second use case was for performance and debugging. They would record short clips to play back and profile a range of hardware. I wanted to share with you a brief clip and a quote from Zero Light's technical director, Chris O'Connor. And I'll play the short clip from one of the recordings right here. So this is from a VR experience you all are welcome to check out at the, this is for Lucid. They have a new vehicle called the Lucid Air, and it's an electric vehicle. The VR experience is hosted in their showrooms throughout the United States and globe. And it really helped consumers go in and understand the color selection and material selection inside their vehicles. Because there are a number of different colors and materials, they could see samples or swatches in the showroom, but the VR experience really enabled them to make more informed buying decisions. So I mentioned collaboration earlier. Another useful VCR feature enables a single user to capture multiple VR sessions with one HMD, then play multiple captured sessions back on separate computers. Here's a video that I'm going to show you about multiple VR sessions played back simultaneously in Autodesk VRED. VRED is an automotive visualization app that also supports VR collaboration. This example is really a productive way to test a collaborative VR application without having to have multiple VR users, and really the only limitation is the number of instances you choose to run simultaneously.
Here you see me using Autodesk VRED, and I'm capturing different interactions in a set of tracking segments. I'm capturing interactions to jump to different viewpoints in the scene, and to perform some actions depending on the viewpoint, like opening and closing doors, or waving to other viewpoints. I then took the data that I recorded and copied it to multiple systems, all running Autodesk VRED and the VCR replay component. On each of those systems, I replayed a different viewpoint teleport action and looped the replay of the according interaction segment. Putting all of these virtual replay systems into a collaborative session resulted in this video. Since every system's loop is differently long, the interactions constantly change. If your use case requires the replays to be synchronized, it would be possible to do so with an additional tool. With the right infrastructure in the background, it could also be possible to synchronize interactions so that it actually looks like a real-world scenario. All of these recordings could also come from a multi-user VR session where everyone interacts with each other and records their own session. Replaying this on multiple systems would be a recreation of this real-life collaborative session.
So I wanted to expand on the diagram you guys just saw in the video, how to capture and playback, how capture and playback is done within VCR. In this particular example here, a single VR user could capture 2 VR sessions. Then each recorded VCR session is copied to a computer to be played back in the same VR app using a collaborative supported VR application. A physical person in VR could host a session and invite two computers to join and play back their recorded session. So once they're recorded, then you have a host in a collaborative app. They're actually in VR, in VR physically, well, as a physical person, and then invite two computers to join. Then you could actually add an additional layer. You could invite a third guest who could join the collaborative VR session, but from the desktop. This desktop view would see the VR host as well as the two pre-recorded VR users. When I first built this diagram, it made sense to me, but then I go, well, I think one more slide would help to kind of put it all into context. So here you have a visual example. On the left, notice the VR session host. This is the avatar that is a live VR user and can see the two pre-recorded VR users on the right in the background. And in this particular example, the third guest is the desktop view, which is the blue border, and the live VR user with the two pre-recorded VR users. The potential here is using a recorded virtual host or instructor to guide you through an application's menus, virtual space, or training exercise. So in addition to Zero Light, we shared the VCR SDK with a couple of our partners. One was Autodesk, and this is a quote from Danny Tierney on the VRED team. One more quote we wanted to share was from ESI. ESI is another ISV that supports design application, a VR application for design and manufacturing and training. So it was really, really helpful to get real-world feedback from our user base just to understand how to improve our VCR SDK. So really briefly, to run through how does VCR work? So the blue boxes represent the components in your standard VR pipeline. VCR is an open VR background application. It stores HMD and controller properties and captures and logs headset and controller motion and controller inputs. VCR works with OpenVR-based applications and SteamVR. VCR is free of charge and supports NVIDIA VR-ready GPUs, works with tethered HMDs, as well as streaming via CloudXR. For replay, VCR uses an OpenVR driver to emulate an HMD in controller and sends a virtual VR driver to SteamVR. VCR reads the saved tracking data and replays the HMD and controller motion and input. In addition to record and playback, the saved hardware properties, specifically headset resolution and frame rate, can be edited in a JSON file, so various HMD resolutions can be replayed without having to recapture using multiple HMDs. Lastly, I wanted to cover VCR filtering. Here we have an example of how you can edit and filter your VCR captured session. From a captured session, you can create a VR video with a smoother camera path, add inputs, slow down or speed up motion inputs, as well as cut out or repeat clips of your captured VR session. In this example, you have on the left a captured controller input, and on the right, the filtered playback.
Here I am recording some motion with a high frequency component, the squiggles, and a low frequency component, the left and right sweeps. And then I'm showing what it looks like when you apply the filter that averages and smooths the positional data. And that yields the same low frequency motion, but removes the high frequency component as expected.
So with the VCR SDK, developers and end users can really extend the core functionality to create even more or additional use cases. Developers can analyze the motion tracking data and better understand how VR users navigate a scene or view a model. Snapshots and timestamps can be created based upon gaze and duration where the user pauses to look in a particular scene. And editing VCR recorded files makes removing invalid controller inputs or retiming HMD motion paths much easier without having to re-record VR user inputs in a scene. And as you saw in the previous slide, now you have another way and a much easier way to create VR video content by being able to edit and repurpose and share these VR experiences as a saved movie. So that's my wrap up for VCR SDK. If this is something you guys are interested in, please look at on our website. We have an early access program. You can sign up. We have a few questions just to understand your use case. And I'm really interested in your guys' feedback if this something looks like it's valuable to your development. And you can also reach me and our development team at vcroutreach@nvidia.com. Thank you very much. Yeah, I can do that. Is that okay?
Anyone have any questions? We have 4 minutes.
Hey, just a quick one.
Yes.
For applications that have like a login, like VR chat, right? So, is there difficulties with like having multiple? Like, does it create a whole new user, or is it kind of like 2 headsets on the same account?
No. Once your application is running through SteamVR,
Yeah.
you set yourself up in a specific location, and basically you essentially hit record, and it starts capturing what is going through the headset. So it doesn't make a difference about the 2 logins.
Okay. I mean, for like a replay. So if you want to replay something on that, does it create like? Is it still on the same single account?
Yes.
Okay.
Yes. Yeah. What it's doing essentially is SteamVR is playing. You turn on your application. You're running it through SteamVR. You turn off. You have to be sure to turn off your headset, and then when you hit play, you are going to install. It's very one click. It installs a virtual driver, so that the SteamVR runtime just thinks that there's a real connected HMD, and it's no. You have one or the other. Yeah. Yeah. Great question. Yes.
I have a quick question. So I was very interested about the overlay, right? So you have your 2, 3, and the original
Yes.
the host, right? So how do you manage conflicts? So when you have a conflict there of actions, is
Right.
that... Yep.
Right. Well, what happens is, first of all, when you have multiple users, you need to have a collaborative application. So if your application doesn't support
I see.
collaboration,
Right.
then it won't work.
It would work, okay.
So what happens is if you have an application that is normally multiple VR users, then you just invite each guest, and then each computer is playing a version of that VR user. So instead of direct HMD and controller input,
Right.
it's playing the tracking file.
Okay, got it.
Okay. Okay. Yep. One more question.
So if I understand this correctly,
Yeah.
because you're putting your own driver,
Yep.
even if the headset's not plugged in,
Right.
it'd still work, right?
Yes, that's right.
Okay, great, thanks.
Yeah, no problem. Great question. Thank you very much.